So hey guys, hello and welcome back to my channel. This is me Pritham Paikrai and you are watching Step 2 Math. So today in this class we will be discussing about the polynomials. So what are polynomials? So a polynomial basically it is an expression that is written in a particular manner. Okay, so let me write the expression first, then we will discuss about the polynomials. So let me write this is equals to p of x is equals to a naught plus a1x plus a2x square so on up to an x to the power n, where an is not equals to 0 is called a polynomial of degree n, where n is a non-negative integer and a naught, a1 up to an are real numbers. And x is called the variable. So here I will be saying, okay, p of x, it is I will be saying it is a polynomial is an expression that is in the form px is equals to a naught plus a1x plus a2x square likewise up to nx to the power n is called a polynomial of degree n, and this n is nothing but that is a non-negative integer. Okay, so and this a naught, a1 up to an, these are real numbers. They are called the coefficient of the polynomials, and x is called the variable of the polynomial p of x. So what is actually degree of a polynomial? So let me define that. So degree of a polynomial p of x is the highest power of x in px. Okay, that is the highest power of x in px. That means I will be saying, okay, here the highest power of x is n. So I will be saying, okay, this is a polynomial of degree n. So if p of x is equals to a naught is not equals to 0, then p of x is called a constant polynomial. Okay, so I'll be saying this polynomial to be a constant polynomial. So you can see by the definition of degree of a polynomial, the degree of this constant polynomial is, so degree of px is 0. Okay, so you can see the highest power of x in this px is equals to 0. So I'll be saying, okay, fine. So this polynomial is having the degree 0. So if I'll be saying p of x is equals to 0, means if this a naught is equals to 0, then what will happen? So this polynomial, then p of x is called as a zero polynomial. Okay, so this is called a zero polynomial. So then what is the degree of this polynomial? So clearly you can see, if I will be saying it is a zero polynomial, that means a naught is equals to 0 and all these terms are 0. Okay, so and this an is not equals to 0. If this an is not equals to 0, then this is called a polynomial of degree n. So here you can see a naught is equals to 0. So I am saying it is a zero polynomial. This implies the degree of this polynomial is, degree of px is not defined. Okay, so we have not defined what will be the degree of the polynomial, what is the degree of the zero polynomial. Okay, so now let us take some another polynomial, that is px is equals to a naught plus a1x. Okay, a naught plus a1x. So this polynomial is called a linear polynomial. Okay, so it is called a this is called a linear polynomial. Why this is called a linear polynomial? This is called a linear polynomial because the degree of this polynomial p of x is 1. So because degree of px is plus a1x plus a2x square. So this is called a quadratic polynomial. So this is called a quadratic polynomial. Okay. So this is called a quadratic polynomial. So any polynomial of degree 2 is called a quadratic polynomial. Similarly, any polynomial of degree 3 is called a cubic polynomial. So this is called a cubic polynomial and so on. Okay, so let me give you some particular examples of a constant polynomial, a linear polynomial, a quadratic polynomial as well as a cubic polynomial. So let us give some examples. So if I will be saying, okay, let me say px is equals to 2. Okay, suppose I will be saying px is equals to 2. So px is equals to 2. So here you can see this a0 is equals to 2 and a1 is equals to, obviously it will be 0. So I cannot, so I will be saying, okay, so this is an example of a constant polynomial. Okay, because this is a polynomial of degree 0. So similarly, I can say p of x is equals to 2 plus 3x. So this is the example of a linear polynomial because the degree of this polynomial is 1. Similarly, I can say p of x. So I will be giving some example. Px is equals to 3x. So px is equals to x. So all these are the examples of linear polynomials. So similarly, p of x is equals to x square. P of x is equals to x square plus 3x plus 2. X square is px is equals to, so px is equals to let me say x square, 2x square plus 4x. So all these are the examples of quadratic polynomials because you can see here the degree of this polynomial is 2. So likewise you can give examples of cubic polynomials. Okay, so all these are the examples of cubic polynomials. So one thing you notice here, so what I am doing is here that I will be just considering the polynomial and I will be seeing what is actually the degree of the polynomial, and by knowing the degree of the polynomial, I will be naming the polynomial as my constant polynomial, linear polynomial, quadratic polynomial, or to be my cubic polynomial. Okay, so okay, fine. Let me give you let me give you another definition. If I am saying px is equals to root x plus 2. Okay, if I am saying px is equals to root x plus 2. So the question is this a polynomial? So is this a polynomial? Okay, so is this a polynomial? So I can write this as x to the power 1 by 2 plus 2. So here you can say the highest power of x is 1 by 2, which is not an integer. So I will be saying, okay, this is not a polynomial. Okay, so similarly, px is equals to 1 by some 2x plus 1. Okay, so here you can see I cannot write this px is equals to a0 plus a1x up to an x to the power n. So I will be saying yes. So this is not an example of this polynomial p of x is equals to 1 by 2x plus 1. This is not an example of a polynomial. Okay, so let me give you another definition. So if p of x is a polynomial, so if p of x is a polynomial in x, and if k is say any real number, then pk is called the value of p of x at x is equals to k. So if p of x is a polynomial in the variable means in x and k is any real number, then I will be saying pk is the value of the polynomial p of x at x is equals to k. So what I am doing here is that I am just replacing x by k and I will be giving the particular value to that x, so that I will be getting a particular real number, so that real number will be called my value of that polynomial at that real number x. So let me say if I will be considering p of x is equals to 3x square plus 2x plus 1. Okay, suppose px is equals to 3x square plus 2x plus 1. So if kx is equals to 2, that means I will be considering k is equals to 2. So this implies p of 2 is equals to 3 into 2 square plus 2 into 2 plus 1. So this is 12 plus 4 plus 1. So it is 17. So I will be saying yes. So the value of the polynomial p of x at x is equals to 2 is 17. So similarly, I will be saying p of 5 here will be 3 into 5 square plus 2 into 5 plus 1. So this will be equals to 75 plus 10 plus 1. So it is 86. Okay. So the value of this polynomial p of x at x is equals to 5 is 86. Okay. Likewise, we can find the value of polynomial p of x for any value k. So this is our value of a polynomial at some point. So what is actually the significance of this definition? So we will be seeing this in the next class. What is a polynomial? So in the next class we will be discussing about the geometrical interpretation of this zero of the polynomials. So what will be the zero of a polynomial, linear polynomial, constant polynomial, cubic polynomial, quadratic polynomial? All these things we will be discussing in the next class. But today it is all about our definition and examples of the polynomials. So thank you for watching this. Stay safe and stay healthy.